If humans were to live on Mercury, the smallest planet in our solar system, it would present a variety of challenges due to its extreme conditions. Here are some potential outcomes of living on Mercury. Extreme temperatures. Mercury's proximity to the Sun means that it experiences extreme temperature variations, with surface temperatures ranging from -173 degrees Celsius -280 degrees Fahrenheit, at night to 427 degrees Celsius, 801 degrees Fahrenheit, during the day. This extreme heat would make it difficult to survive on the planet's surface. Lack of atmosphere. Mercury has a very thin atmosphere, which means that there is little protection from solar radiation and meteorite impacts. This would pose a significant risk to any human inhabitants. No water. There is no evidence of liquid water on Mercury, and the planet's surface is characterized by vast deserts of rocky terrain. This would make it challenging to find water or grow crops. Gravity. Mercury's gravity is only 38% that of Earth's, which would cause challenges for human physiology and could lead to health problems for long-term residents. Limited resources. Mercury has limited natural resources, including minerals, metals, and energy sources. This would make it difficult to sustain human settlements on the planet. Despite these challenges, there are potential benefits to living on Mercury. For example, the planet's proximity to the Sun could make it an ideal location for solar power generation. The lack of atmosphere also means that Mercury has some of the clearest skies in the solar system, which could be advantageous for astronomical observations. Overall, while living on Mercury presents significant challenges, it is not entirely impossible. However, significant technological advancements would be required to make it feasible, and it is unlikely that humans will inhabit the planet in the foreseeable future. If humans were to live on Mercury, the smallest planet in our solar system, it would present a variety of Fahrenheit. This extreme heat would make it challenging to survive on the planet's surface. Atmospheric pressure. Venus has an atmospheric pressure that is more than 90 times greater than Earth's. This pressure would require the development of specially designed structures to protect human habitats. Toxic atmosphere. Venus' atmosphere is toxic, with clouds of sulfuric acid and other corrosive substances. This would make it challenging to create habitats and infrastructure that could withstand the planet's environment. Lack of water. Venus has very little water, and any water that exists on the planet is in the form of acid rain. This would make it challenging to grow crops or sustain human settlements. Limited resources. Venus has limited natural resources, including minerals, metals, and energy sources. This would make it difficult to sustain human settlements on the planet. Despite these challenges, there are potential benefits to living on Venus. For example, the planet's atmosphere could be used as a source of carbon and other elements. Venus' proximity to the Sun could also make it an ideal location for solar power generation. Overall, while living on Venus presents significant challenges, it is not entirely impossible. Significant technological advancements would be required to make it feasible, and it is unlikely that humans will inhabit the planet in the foreseeable future. However, research and exploration of Venus could lead to important discoveries about the formation and evolution of our solar system. If humans were to live on Venus, the second planet from the Sun, it would present a wide range. If we were to live on Mars, there would be many changes and challenges to our daily lives. Mars is the fourth planet from the Sun and is known as the red planet due to its reddish appearance. Here are some ways living on Mars would affect our lives. Atmosphere. Mars has a very thin atmosphere, which means that it cannot protect us from harmful radiation from the Sun. This would make living on the planet difficult and would require us to build habitats that can protect us from the radiation. Gravity. Mars has a weaker gravity than Earth, which would cause many changes in our bodies. Astronauts who have spent long periods of time in space have experienced muscle and bone loss due to the lack of gravity, and living on Mars would be no different. Temperature. Mars has a very cold and harsh climate, with temperatures averaging around -80 degrees Fahrenheit, -62 degrees Celsius, at the equator. This would require us to build habitats that can protect us from the extreme cold and harsh winds. Water. Mars has frozen water at its poles and underground, but it is not easily accessible. We would need to find a way to extract and purify the water in order to use it for drinking, growing crops, and other necessities. Agriculture. Growing food on Mars would be a challenge due to the planet's thin atmosphere and cold temperatures. We would need to create greenhouse environments that can maintain stable temperatures and provide sufficient light for plants to grow. Overall, living on Mars would require us to adapt to a very different environment than we are used to on Earth. It would be a difficult and challenging endeavor, but it could also lead to important decisions. Living on Jupiter would be extremely challenging, as the planet's harsh environment and lack of a solid surface make it uninhabitable for humans. Jupiter is a gas giant, meaning that its surface is composed primarily of hydrogen and helium gas, with no solid ground to stand on. Its atmosphere is also incredibly turbulent, with powerful storms and winds reaching up to 620 km per hour. The intense radiation and magnetic fields around Jupiter would also be a major obstacle to human habitation. These fields are generated by Jupiter's rapid rotation and strong magnetic field, and can cause significant damage to electronics and biological organisms. Another major challenge is Jupiter's extreme temperature. At the top of its atmosphere, the temperature can reach a frigid -145 degrees Celsius, while deeper within the planet, temperatures can reach tens of thousands of degrees Celsius. This would make it incredibly difficult to maintain a livable environment for humans. Overall, it is highly unlikely that humans will ever be able to live on Jupiter, given the extreme conditions and lack of a solid surface. However, studying Jupiter and its environment can still provide valuable insights into the formation and evolution of our solar system. Living on Saturn shares extreme conditions with Jupiter, making it challenging to live on. It's a gas giant with no solid surface and a turbulent atmosphere. Powerful storms and winds reach up to 1,800 km per hour. Intense radiation and magnetic fields pose a major obstacle to human habitation. Intense radiation and magnetic fields pose a major obstacle to human habitation. Fields are generated by Saturn's rapid rotation and strong magnetic field. They can cause significant damage to electronics and biological organisms. Saturn is even colder than Jupiter, with temperatures reaching -185 degrees Celsius. Its rings create a hazardous environment with high levels of debris and dust. This could cause damage to any structures or equipment. Saturn shares many extreme conditions with Jupiter. It's a gas giant with no solid surface to stand on. Its atmosphere is incredibly turbulent with powerful storms and winds. Intense radiation and magnetic fields pose a major obstacle to human habitation. Fields are generated by Saturn's rapid rotation and strong magnetic field. They can cause significant damage to electronics and biological organisms. Saturn is even colder than Jupiter, with temperatures reaching -185 degrees Celsius. Its rings create a hazardous environment with high levels of debris and dust. This could cause damage to any structures or equipment. It's highly unlikely that humans will ever live on Saturn. However, studying Saturn and its environment can provide valuable insights. Saturn's extreme conditions can help us understand the formation and evolution of our solar system. Living on Saturn is highly unlikely due to extreme conditions and lack of a solid surface. Studying Saturn can provide valuable insights into our solar system's formation and evolution. Saturn. Neptune is a gas giant planet located in our solar system and is much different from Earth. _circle. If humans were to live on Neptune, they would face significant challenges due to its harsh environment. Firstly, Neptune has no solid surface for humans to stand on, and its atmosphere is composed mainly of hydrogen and helium, with small amounts of methane and other gases. The extreme pressure and temperature conditions found in Neptune's atmosphere would be deadly to humans without proper protection, and the lack of breathable air would make it impossible to survive without special equipment. Additionally, Neptune is located very far from the Sun, and its surface receives very little sunlight. This means that any human settlements on Neptune would have to rely on alternative sources of energy, such as nuclear or geothermal power, to survive. Furthermore, Neptune is a very hostile environment with high winds and intense storms, including the famous Great Dark Spot, a massive storm system larger than Earth. These storms would be extremely dangerous to humans and any infrastructure that they built on the planet. Overall, while the idea of living on Neptune is fascinating, the reality is that it is an inhospitable environment that would require significant technological advancements for humans to survive. It is also worth noting that the distance between Earth and Neptune is immense, making it very difficult and expensive to transport humans and resources to and from the planet. The journey to Neptune would take several years with current technology, and the physical and psychological toll on humans during such a journey would be significant. Moreover, the extreme conditions on Neptune would pose significant challenges for the development and maintenance of any infrastructure or settlements. The equipment and materials used on Earth would likely not be suitable for use on Neptune, and new technologies would have to be developed to withstand the planet's harsh environment. In conclusion, while the idea of living on Neptune is intriguing, the reality is that it is currently beyond our technological capabilities and would require significant advances in science and engineering to make it possible. It is important to continue exploring and studying our universe, including planets like Neptune, but for now, Earth remains the only known planet that can sustain human life. Neptune has 14 known moons, with the largest being Triton. Triton is a unique moon because it is the only large moon in the solar system that orbits in the opposite direction of its planet's rotation. It is also thought to be a captured object from the Kuiper Belt, a region beyond the orbit of Neptune that contains many icy objects. Other notable moons of Neptune include Nereid, which has an irregular and highly elliptical orbit, and Proteus, which is one of the largest irregularly shaped objects in the solar system. The moons of Neptune are thought to be composed of a mixture of rock and ice, and many have heavily cratered surfaces due to impacts from space debris. The moons of Neptune have been studied extensively by spacecraft, including the Voyager 2 mission in 1989 and the more recent New Horizons flyby of Pluto, which also conducted a brief survey of the Neptune system in 2014. These missions have provided valuable insights into the composition and origins of these distant worlds, and have expanded our understanding of the outer solar system. Neptune is a gas giant planet located in our solar system. Uranus is a gas giant planet located in our solar system and, like Neptune, is much different from Earth. If humans were to live on Uranus, they would face significant challenges due to its harsh environment. Firstly, Uranus has no solid surface for humans to stand on, and its atmosphere is composed mainly of hydrogen and helium, with small amounts of methane and other gases. The extreme pressure and temperature conditions found in Uranus' atmosphere would be deadly to humans without proper protection, and the lack of breathable air would make it impossible to survive without special equipment. Additionally, Uranus is located very far from the Sun, and its surface receives very little sunlight. This means that any human settlements on Uranus would have to rely on alternative sources of energy, such as nuclear or geothermal power, to survive. Furthermore, Uranus is a very hostile environment with high winds and intense storms, including the famous polar vortex, a massive storm system located near its north pole. These storms would be extremely dangerous to humans and any infrastructure that they built on the planet. Overall, while the idea of living on Uranus is fascinating, the reality is that it is an inhospitable environment that would require significant technological advancements for humans to survive. It is important to focus our efforts on protecting and preserving our own planet, rather than trying to colonize other planets that may not be suitable for human life. Uranus has 27 known moons, with the 5 largest moons being Miranda, Ariel, Umbriel, Titania, and Oberon. These moons are believed to have formed from the debris left over after a giant impact between Uranus and a Mars-sized body, which is thought to have caused Uranus to tilt on its side. NASA has not yet sent a dedicated mission to explore Uranus, although there have been proposals for future missions. In the 1990s, the Voyager 2 spacecraft flew by Uranus and provided the most detailed observations of the planet to date, including close-up images of its moons and rings. There are currently 2 proposed missions to Uranus under consideration by NASA, the Uranus Orbiter and Probe mission, which would send an orbiter to study the planet's atmosphere and magnetic field, as well as a probe to explore the planet's interior, and the Uranus Pathfinder mission, which would send a flyby spacecraft to study Uranus and its moons. Exploring Uranus and its moons could provide valuable insights into the formation and evolution of the outer solar system, as well as help us better understand the conditions and potential habitability of other icy worlds in our solar system and beyond. Uranus is a gas giant planet located in our solar system, and living on Pluto would be a daunting task, as it is a distant and frigid dwarf planet located at the edge of our solar system. With an average temperature of -375 degrees Fahrenheit, -225 degrees Celsius, it is much colder than any place on Earth, and its atmosphere is very thin and composed mainly of nitrogen and methane. Firstly, Pluto has no solid surface for humans to stand on, and its environment would be hostile to human life. The extreme cold and low atmospheric pressure would make it impossible to survive without special equipment and protective suits. Additionally, because Pluto is so far from the Sun, it receives very little sunlight, which would make it difficult to generate energy and support human settlements. Alternative sources of energy, such as nuclear or geothermal power, would likely need to be used. Furthermore, Pluto has a very thin and tenuous atmosphere, which would not provide adequate protection from cosmic radiation and other hazards. Any human settlements on Pluto would require extensive shielding to protect against these hazards. Overall, while it is unlikely that humans will ever live on Pluto due to its hostile environment, there is still much to be learned about this distant world. NASA's New Horizons mission, which flew by Pluto in 2015, provided unprecedented insights into Pluto's geology, atmosphere, and moons, and future missions may continue to uncover new discoveries about this fascinating dwarf planet. Pluto has 5 known moons, named Charon, Nix, Hydra, Kerberos, and Styx. Charon is by far the largest of these moons and is actually large enough to be considered a dwarf planet in its own right. If humans were to live on Pluto, they would face many of the same challenges as they would on Neptune, such as the lack of breathable air, extreme temperatures, and harsh conditions. In addition, Pluto's distance from the Sun means that it receives very little sunlight, which would make it difficult to generate energy and grow food. The harsh environment on Pluto would require humans to rely on advanced technology and infrastructure to survive, such as underground habitats that are shielded from the extreme temperatures and radiation. Any human settlement on Pluto would also need to be completely self-sufficient, as resupply missions from Earth would be extremely difficult and expensive. NASA's New Horizons mission, which launched in 2006 and conducted a flyby of Pluto in 2015, provided important insights into the dwarf planet and its moons. The mission revealed many previously unknown features on Pluto, including a large heart-shaped region on its surface, as well as a diverse landscape of mountains, valleys, and plains. New Horizons also conducted flybys of Pluto's moons, providing important information about their composition and structure. For example, the mission revealed that Charon has a heavily cratered surface and a large canyon system, suggesting that it may have experienced significant geological activity in the past. Overall, while living on Pluto would present many challenges, it remains an intriguing destination for scientific exploration and discovery. Living on Pluto would be a daunting task, as it is a distant and frigid dwarf.